And then I'm really excited to introduce Marco de Leonardis. As I had mentioned, he is the R&D operations manager at Freeman Herbs, and we've been working with them for a couple of years now, and he'll be telling his story as well. So go ahead, Marco.
Hi, my name is Marco de Leonardis, and I'm a manager of research and development at Freeman Herbs. When I joined the company, one of the goals that was given to me, it was to have a comparable growing time for the herbs during the summer and winter. So it was obvious that we needed a supplemental light in these northern conditions. And so I did a lot of research on different lights, and to get the supplemental lights, I could have used HPS, HID, LED. So why did I choose to go to LED? Well, while I was doing this research, I was coming across all these trials and experiments that the people are doing, because LED is a relatively new technology used in agriculture. And what struck me, it was that to be able to control the spectrum would have given me so much power in doing what we're doing. So the first thing that I wanted to do, it was to be able to control the architecture of the plant. So we grow herbs, and for example, parsley or dill or cilantro, they have a hypocotyl that gets quite long. So when the plant becomes big, the plants flop down because the hypocotyl can't hold the weight. So one of the things I had to do, I had to reduce the hypocotyl. Well, by changing the ratios of blue, red, and the light, it allows me to do that, because we know that if we have a higher blue, the hypocotyl stays short. I mean, this is common knowledge that you can find, but you need a tool to do that. There was a study done in Israel that they use color screen to change the spectrum. Well, it's a little bit intensive work to do that, so the light allows us to do that. So the other things that it's very important for us, which we use with success, is that when we receive orders, we sell live plants in a pot, and they have to meet a certain standard. If they grow too big, the customer will not take them. Or if they are too short, the customer will not take them. Well, by knowing in advance, we can accelerate the growth, or by changing the spectrum again, increasing the red, or as it happened, we had an order that was delayed by 2 weeks. Well, we put it on a very high blue spectrum, we managed to save all the plants. In another year, we would have thrown away the whole production as a shrinkage. So that's a very big plus, because the lights are expensive, but when you get these tools, you actually save money. And not only, they use much less energy than HPS or HID. The other things that we do, we've done a research like lately with LumiGrow, and we are looking into repeating this experiment. We're trying to find a perfect recipe for each herb. So we grew some problematic herbs with different ratio spectrum, and then we observed what the results were. Now, with these results, we will be able, which next step, to make a mixed recipe. So let's say start for the first 2 weeks with a ratio, then do the main growth with a different ratio, and finish the plant with another ratio. Because like that we can control color, taste. I mean, if you have a higher blue towards the end of the growth, because it creates more cell per square inch, you will get much more flavor. And if we have a plant that has got a better color and a better flavor, we beat all competition. So that again, it's a big plus that makes logical to spend a little bit more money when it gives you the tool of being able to control the spectrum. And the last thing I'd like to tell you is another very big successful thing is which Brian mentioned. We had a case of downy mildew on basil, Peronospora belvari. Peronospora belvari, it's a disease that has got no cure. There has been a lot of research done to have plants of basil resistant to this disease. But up to now, I can tell you there is nothing that works. If the plants get the downy mildew, very likely you lose the whole production. Well, we didn't. What we did was we used a full red spectrum throughout the night for the time when there was the high pressure. We had the disease, but we had no sporulation. So when we had the lights, we had no sporulation. We maybe threw away 1 or 2 plants instead of tens of thousands of plants. Because, that's our production. So that again saved so much money to us that it makes logical to invest in a dynamic LED light, because a static LED light will not allow you to do that. You need to have the possibility of increasing the spectrum at your will. Thank you.
Thanks so much, Marco. And we will be deploying the integrated light sensor at your facility very soon. So I wanted to ask you, from a commercial perspective, what are you most excited about in terms of the light sensor, what it can do at your operation?
Well, to be able to have a DLI sensor that can be programmed so that we know what the target DLI is for, let's say, our basil. And I know that I want to reach the DLI, which is around 15 mole per day. And with a sensor on each light, you would be able to save a lot of energy and use the lights when you will not even think about using them. For example, in a summer day, you think, oh, I get plenty of light. Well, if it is very cloudy, you might not reach that 15 mole. And with a sensor, the light can adjust itself to get that target you decided. And it's a no-brainer because it takes away all the stress of thinking. It avoids to use too much light. You can't go with your spectrometer and see, okay, how much I'm getting. Okay, I have to increase this. It's all done automatically. So for me, that's the joy.
Thank you, Marco. I think we're up for time, but I want to thank you all so much for stopping by and hearing what LumiGrow is up to and what we continue to work on. I really encourage you to stop by our booth. The booth number's up there, 2326. We'll be there to answer any questions, whether it's about the fixture, the technology, or about our research findings in our commercial and research installations. So thanks again, everyone.